Hi everyone, I'm Shubham Jhanwar. We are discussing KVPY 2017 SX, and the question for this video is this. The number of solutions of the equation sin theta plus cos theta equal to sin 2 theta in the interval minus pi closed to pi closed is. You can possibly do it in different ways. One way is to square the both sides. So here, upon squaring, of course, some extra roots may creep in, so to speak, and you should check, whatever you get ultimately with the original equation, which is sin theta plus cos theta equal to sin 2 theta. So as you square both sides, the purpose of squaring is sin theta plus cos theta whole square turns out to be 1 plus sin 2 theta, because sin square theta plus cos square theta is 1 and 2 sin theta cos theta is sin 2 theta. So squaring both sides gives you a quadratic in sin 2 theta, because what you get is 1 plus sin 2 theta is equal to sin square 2 theta. So what you get is sin square 2 theta minus sin 2 theta minus 1 is equal to 0. So using the concept of quadratic, the roots of this quadratic in sin 2 theta would be sin 2 theta can either be equal to 1 plus root 5 by 2 or 1 minus root 5 by 2. Now root 5 is 2 point something and 1 plus root 5 would be 3 point something. Divided by 2 would be 1.5 something. So this is greater than 1, hence rejected. Why? Because sin 2 theta can't be greater than 1. Now here 1 minus root 5 by 2, 1 minus root 5 is 2 point something, 1 minus root 5 would essentially be minus 1 point something, by 2 would be minus half point something. So rather that means minus 0.5 something. Yeah. So you may say this lies in this interval minus half, or rather minus 1 to minus half. Yeah, minus 1 to minus half. So definitely it is greater than minus 1. Yeah. And here now, since we have squared and we have got sin 2 theta to be 1 minus root 5 by 2, we would not just go by just this conclusion that sin 2 theta is 1 minus root 5 by 2. Mind it, we have squared the equation. That means we have squared both sides of the equation, and some extra root may creep in. So we should check with the original equation as well. So the point here is not just sin 2 theta is 1 minus root 5 by 2. In fact, sin theta plus cos theta is also 1 minus root 5 by 2, because sin theta plus cos theta is equal to sin 2 theta. Yeah. So here we'll consider the understanding of sin theta plus cos theta, which I believe you should already be having. If you see it carefully and divide the quadrants into these 8 parts, as theta varies, at theta equal to 0, sin theta plus cos theta is 1. Yeah, so what we are talking about is sin theta plus cos theta. Yeah. At this pi by 4, sin theta plus cos theta is root 2, then here it is 1, and we are moving with the interval of jumping the angles by 45 degree, yeah, or increasing the angles by 45 degree. So here this will turn out to be 0, because sin theta would be 1 by root 2 and cos theta would be minus 1 by root 2. Here it becomes minus 1 minus root 2 minus 1 0 and 1. Yeah. And here theta is in this interval minus pi closed to pi closed. Yeah. So minus pi closed to pi closed. So this minus x-axis direction is being considered twice. Nonetheless, here sin theta plus cos theta should be equal to sin 2 theta, which in turn is equal to 1 minus root 5 by 2, which is in turn is between minus 1 and minus half, or you may say between minus 1 and 0. Obviously, yeah, if something is between minus 1 and minus half, it is of course between minus 1 and 0. Yeah. So one root you would get here and one root you would get here. So essentially you would be getting 2 roots only. Now the answer is supposed to be 2. B is the answer. We'll go for some other method also. However, I would like to point out that if you would have just gone by this understanding that sin 2 theta is equal to 1 minus root 5 whole divided by 2, you would have ended up getting more number of solutions, so to speak, wrongly. Why? Because we have squared, and you can't just go by what we have got after squaring blindly. You should check with the original equation as well. So here if theta is in this interval minus pi close to pi closed, 2 theta would be in the interval minus 2 pi closed to 2 pi closed. Yeah. So, making this 360 degree rotation twice, minus 2 pi to 0 and 0 to 2 pi. And sine 2 theta being 1 minus root 5 by 2 being negative, you would get one value in third quadrant and one value in fourth quadrant. And mind it, third and fourth quadrants both would come twice each. Why? Because this is twice 360 degree, minus 2 pi to 0 and 0 to 2 pi. So overall you would have got 4 solutions for theta being between minus pi close to pi closed. But 4 is not the answer, 2 is the answer, and hence you can easily understand that yes, upon squaring you should be extra careful. Let's see another method. We can use graphical approach to find the number of solutions. Yeah. So here what we can do is we can plot the graphs of left hand side sine theta plus cos theta with respect to theta, and the graph of right hand side, yeah, sine 2 theta. Yeah. So this is, let's say, theta axis, and we are plotting sine theta plus cos theta. That means you may say this is y axis, y equal to sine theta plus cos theta, and y equal to sine 2 theta, two different graphs, and the number of intersection points between theta being minus pi to pi would be my answer. Yeah. So here we go. So sine 2 theta graph is quite simple. As theta varies from 0 to pi, 2 theta varies 0 to 2 pi. Yeah. So sine 2 theta would be like this. Yeah. So this is 0, pi by 2, pi. Similarly, it will be like this. Yeah. So this is, you may say, minus pi by 2, and this is minus pi, so to speak. So here, you may say at pi by 4, this is 1, and at pi by 2 it is 0. At 3 pi by 4, this is minus 1. So is it minus 1 at minus pi by 4. This is minus 3 pi by 4, at which it is 1. So all these things are pretty clear. Now let's plot y equal to sine 2, y equal to sine theta plus cos theta graph. So sine theta plus cos theta graph would be, you may say, sine theta plus cos theta is 1 by root 2 times sine, root 2 times sine theta plus pi by 4. So it will be root 2 times sine theta plus pi by 4. Yeah. So when theta is 0, root 2 times sine pi by 4 is 1. Yeah, it is like this here. Yeah. At pi by 4, it becomes root 2. Yeah. At pi by 2, it becomes again 1. Yeah. At 3 pi by 4, it becomes 0, because sine pi would be 0. Yeah, like this. And at pi plus pi by 4, sine pi plus pi by 4 is minus 1 by root 2. Yeah, sine 5 pi by 4 is minus 1 by root 2. So root 2 times sine 5 pi by 4 would be minus 1. So it will be something like this at pi. Yeah, minus 1 it will be. So there is one intersection here, and as you go back and vary theta and change theta in negative direction from 0 to minus pi. So when you put theta to be minus pi by 4, sine 0 it becomes, and hence it becomes 0. Yeah, like this. At minus pi by 2, it will be sine minus pi by 4, which will be minus 1 by root 2 times root 2. So it is minus 1 here. Yeah. And it goes at minus 3 pi by 4 plus pi by 4, it is minus pi by 2. Sine minus pi by 2 is minus 1. So minus root 2 it becomes. Yeah. So here this is root 2. Yeah, at pi by 4, and at minus 3 pi by 4, this is essentially minus root 2. Yeah. And at minus pi, it is minus pi plus pi by 4 is minus 3 pi by 4. So very simply, again it becomes minus 1 here. Yeah. So clearly there are two intersection points, and hence this equation has two solutions. So B is the answer. We have seen two methods. I hope you are able to understand and appreciate. Thanks for listening. Bye.